Thank you very much. Anybody should say if you hear me. Natalie, you hear me?
Yeah, we can hear you very
Okay,
well.
terrific, terrific. Look, it's really very nice to be there, but I wish I was there, and I'm just so regretting the bad times and so wish for a good time there. Um, I am wearing, as you see, between my brain and my heart, the hostage sign. I hope those hostages will be released by before any next meeting that we have. It's right between my thoughts and my pains, and I'm really with you. And thank you, Ilya, and everybody else for organizing this meeting. We're with you in your just cause, and I just hope for rapidly better time. Uh, so what I'm going to do is I'm going to present really something for AFAR because that's the organization that supports. I've been the scientific director of AFAR. I'm now the president of the Academy for Health and Lifespan Research. And by the way, the reason that you have this title is not exactly because that's what's the following talk, but whenever people ask me, have a holding title for your lecture, I do that because my major research is around centenarians and how they get there. But um, from an AFAR perspective, I want to present the FAS initiative, that aims to use omics to determine geroscience biomarkers that are using existing trial. Now, you must be wondering, what do you mean existing clinical trials? Do we have any drugs that actually do anything with aging that have been tested in clinical trials? And the answer is yes, and it might surprise you, but let me just make a better introduction. Um, I myself am interested in biomarkers. And by the way, I had on myself 10 biomarkers that showed me that I'm anywhere between 20 years younger than my age to 4 years older than my age. It's not that they're not meaningful, and maybe all of them are meaningful, but we really want to distinct between your whole body biological age and chronological age. My favorite platform is proteomics for many reasons. It's not really important for now, but when I take 1,000 of my subjects, by the way, those are Ashkenazi Jews in my studies, and look at 5,000 proteins by SomaLogic, what I do, and as you know, those volcano plots, that's the statistical axis. So those lava, those hot stones are being, uh, you know, expanded from the mountain, and a lot of them are going up and a lot of them are going down, and that's kind of how of aging looks like. um, if I'm looking at the 500 people of my 1,000 that are just regular people who are aging out of the community, you can see really the same. But more important, if you look at offspring of centenarians, and offspring of centenarians are living longer and without diseases, they have half the heart attacks, half the Alzheimer's, half the death. You can see that they're more pink than red. In fact, they have only 235 significant protein changing versus 585. They're 10 years biologically younger than their age. So if you wait 10 years, maybe they'll get there. By the way, it's the same with women. Women have much less proteome that are changing between 65 and 95 than men. And it's really important to know it's 277 versus 600. And it's important to know because when we're developing tools, maybe we use only the ones who are male and female together, or maybe we need to have totally proteome for male and females aging. It's also possible that women are actually 4 years younger than their biological age, and that's why we're seeing those difference. But I'm showing you all that because when we're looking at what is really changing in those ages, what's really impressive is its breakdown of proteins that we measure in the plasma. our first pass here was there's a lot of extracellular metrics, degradation of extracellular metrics, platelet degranulation, collagen degradation, neutrophil degranulation, etc., etc. And and the reason I'm telling you is two things. One, no matter how we're going to target aging between 65 and 95, we have to stop this breakdown. So I think those proteins are going to be very important. But more than that, we're in a different stage, and I'll just say this is our last Nature paper. It was last December with Tony Weiss-Corey, and it's with our subjects. And we can figure out not only what's the age of the body, but also because of those breakdown, we can see what's coming from the brain, what's coming from the liver, what's coming from the kidney. And we can see not only your whole age, but your organ age. Now, there's 80% correlation between any one of your organs and your age, but it's not always like that. So, for example, we're looking now at those people here who actually have slow aging overall, but their brain here seems to be aging faster. So maybe we can find what's going on in your brain and your liver in order to see if it's disease, if it's leading your aging, and maybe we can do better than just biomarkers. So this is just as now we're in the biomarker field. But this is the problem with the biomarkers. Not all the biomarkers changes when you use gerotherapeutics or geroprotectors. So, and we need biomarkers because we need the population to say, hey, our revolution is we're going to treat your health now, right? So do something and we can measure how it's going. Like we do for cholesterol or hemoglobin A1C or blood pressure, right? We want to see a change. If we do that, of course, we'll have this longevity medicine um, kind of intervention, and we'll get our people, our subject to actually adhere to therapy, because otherwise, you know, if they take a supplement or something, they don't know if it's doing good or not. Okay, so I'm still haven't shown you that we actually have tools and opportunity to measure it now. But I would argue that if we have a gerotherapeutic out there, from a preclinical perspective, they have to change the hallmarks of aging. Hallmarks of aging have been mentioned before. I would say, though, the major thing with hallmarks of aging that they're connected between each other. In other words, I will show you, for example, that we target dysregulation of nutrient sensing and we're going to affect immune decline and inflammation. Okay, they're all connected to each other, and every one of the gerotherapeutics that I'm going to show you have changed many of the hallmarks of aging. The second thing that we have to show in preclinical studies, and we saw some great demonstration this morning, thank you for the previous lectures, is that we need an intervention that will actually change lifespan. So if those are animals are living regularly, something makes them dramatically live longer. This is, of course, everybody's it's survival curve. So everybody is dead at the end, but also that they're living healthy. This is from a preclinical perspective. From a clinical perspective, we want to show the following. We want to show that you have a drug, and then when you do a clinical study, placebo-controlled study over 3 years, 5 years, whatever, you can show that this drug that was actually targeting one disease influence other disease or diseases really, okay, a multi-morbidity. And you also want to show that this drug that was designed for something specific is reducing overall mortality, okay? And you're asking, are there drugs like that? And I'll tell you, yes, there are drugs like that. And before showing you, we developed an assessment, and you can see it in those two papers below, that give 6 point for geroscience, because we want them to be geroscience really making sense from this perspective, and six clinical points. So the maximal that you can have is 12. And those are the drugs that are out there. And in pink are the drugs that got over 10 points. We are actually reorganizing those tables, and we'll have a different system. It might change a little bit, but those are the drugs: SGLT2 inhibitors, metformin, biphosphonate, and GLP-1 receptor agonist. First of all, two things I want to mention. Rapamycin is not making it because we really don't have very good uh, studies on rapamycin. Remember, in humans, it's given as an immune suppressor in very high dose. So we don't have really good clinical data on rapamycin, so it stayed out. Um, Second thing that I want to mention is some of the drugs here, okay, in clinical studies have shown to prevent mortality, hospitalization, and long COVID, okay? Connecting by the fact that when you give those drugs, it's not only about, what you think they're doing, they're changing all the hallmarks of aging. So let me give an example. Let me just start with SGLT2 inhibitor that is our best winner here, at least in this system. And you see here a study, I'll just take this graph, but this study is giving them in the intervention testing program, the NIA program, giving it to mice and showing that mice who have those are living longer. Um, and they also lived healthier, but it's really dwarfs compared to primary outcomes of another SGLT2 in humans, and that's in 2020. And since then, there's so much more data that is really unbelievable. And this is a study that included 4,000 people for 2.5 years. That's all. And in 2.5 years, you have 44% in decrease in renal specific mortality. But by the way, those drugs were designed for diabetes. That's what we're designed. And by the way, also half of the users are not diabetics anymore because they are for those other diseases. So renal specific outcome has decreased, a 30% decrease in cardiovascular outcome, and 40% and about 30% decrease in death from any cause. Okay, so you give this drug for something, and all of a sudden, it changes everything. Really, it changes aging. I'll give you a fast example of health outcomes for all those four drugs. This is from another study. 28% decrease in cardiovascular and renal outcome. This is from metformin and heart failure, 30% decrease in heart failure. Biphosphonates, 33% decrease in cardiovascular outcomes. And SGLT2, 22% in renal outcomes. We know that SGLT2 are giving for other things. And by the way, SGLT2 I'm using it in my clinics for diabetes for 8 years now. Um, uh, and now we use it more for obesity, and in obesity we see outcomes that are renal and other outcomes, and it's the same for mortality. 32% decrease in any kind of mortality. Metformin, 24% decrease in diabetes with arteriosclerosis. Biphosphonates, if you're a woman in ICU with biphosphonates, your chances of dying is 50% less. And the same GLP-1, 50% decrease in mortality. So I just showed you very quickly evidence that those drugs are FDA approved, they're out there, and they have major effects, not on one disease, not on two diseases, but on many diseases and on death. And it's very important for us to start doing a repurposing of FDA approved drugs by physicians. Okay, we don't want biologies or, Brian Johnson to tell you what to take. We want MDs involved. And the advantage is there are safety, efficacy, and years of data for each one of those drugs. Now, when you're a physician, you're repurposing the drug, it's legal, okay? You can do it. We're very conservative, but you can do it. Metformin has been repurposed for obesity, not the best drug. Used to be kind of okay, not the best drug anymore. Polycystic ovary syndrome, that's the first drug of choice. Pre-diabetes clinical study showed if you have a risk of diabetes, it'll prevent diabetes by 30%. And as I said, for COVID. So now, why not for aging? I would say that what we're dealing with now is to actually come with a guideline for physicians of how to use this drug. And we always are going to be in a situation where we are going to save 100 and kill 3. And we have to be better at choosing those 100 and excluding the 3. And our notion is, let's do kind of a secondary prevention kind of study. Let's take people who are already older, over 65, maybe have something else, maybe already had an age-related disease, and then look at all those studies and find more indications that will help you choose which one of those you're going to use. Okay, and this is just a preliminary uh, data, so please don't use it, but that's how we're going to populate it. So if you have cardiovascular disease, anyone is good, right? But maybe if you want to prevent flu or COVID, there are some that are better, or that we know they are better. Macular degeneration, if somebody has, we have 2 that have shown that. We have several drugs that show to affect cognition, etc. So the FAST initiative that is ongoing, it's now a proposal that is joining to ARPA-H, is to take studies that were done with metformin, with GLP-1, with SGLT2, with biphosphonates, do the omics, all the omics in the world on them, and see what is specific for each one of them. But more important, what together, what are which biomarkers they're changing together, so we know that they're changing aging. We're doing it with an extensive committee, and you see some of the people here supported by a FAR. And I guess that was the last slide that I was going to show. So the future is, we have to spend time with our health rather than spend time with the disease. This is the revolution, and we have the tools to do it right now. Thank you very much. I miss you, and I'll see you soon.
Thank you very much, Nir. Fascinating talk. Any questions? Maybe I can start. Nir, do you have enough information to compare between healthy individuals and those who have an underlying disease in terms of the use of these drugs in both safety and efficacy?
Oh, I absolutely. I want to say, it reminds me to say something else. All those drugs have been tested in people over the age of 50. Some of them are harmful, in my mind, in people less than that. If you're not metabolically altered, okay, and you take metformin at the age of 40, it's dangerous for you. It lowers IGF-1, it lowers testosterone, it wouldn't let your muscle grow. Okay, so they all have things. But this is how we do it. In every clinical study, okay, you go to any of the top journal, they have the major results, and sometimes within the major results or the supplements, they have another table. And in the table, they say, those above 65 and below 65, did it change the results? Men versus women, was it different? With heart attack, without heart attack, is it different? And this is how we're populating the table. We're going to the sub-analysis and trying to see which drug is better for which individual. And I cannot tell you how many tens of thousands of people have been in clinical studies and how many other studies are out there in all those 4 drugs. So we're very confident on the safety. We're following the rule that we do no harm first, but we have to intervene with that, just like we decided to intervene with lower cholesterol.
Mm-hmm. It takes courage, and I believe that data will be accumulating and analyzed in the future, and so many data points are available. So I'm really looking forward to see that. And I guess also you're probably looking into combined therapies, combinational drugs. Yeah.
Look, yes. A lot of them are changing all the hallmarks of aging, but they're not doing it in the same way. Okay. So we really don't know. Hallmarks of aging are not the mechanism of aging. So they are different between them. But I will also say that we don't know. We know that multi supplements, okay? I mean, supplements, we don't know anything about them and they're not clinical. They're dangerous. But there are some drugs that their combination could be dangerous. For example, rapamycin, SGLT2, metformin are all mTOR inhibitors. So how much mTOR inhibition do we want, right? So I wouldn't say that it's automatic that those combinations are good, but I can tell you that at least in animals, metformin, the combination of metformin and rapamycin are the animals that live the longest. So, but this is not obvious to combine them for now. With the other, what I'm saying, Natalie, is we don't need that much more studies. We have a lot of studies to suggest that we can use them, but things like combination, things like other drugs, we still don't know enough.
Thank you. Any other questions? No? Okay, thank you, Neil.